Hey everyone, my name is Ben, and this is my science experiment. So before we start, here are key definitions that I'll be... First, solute. The solute is this thing that's being dissolved. Solvent is the thing that's doing the dissolving, and the solution is a combination of solutes and solvents that is a homogeneous mixture, meaning that it's the same throughout, so there's no extra sediments or anything. And it could be any state of matter, but it's usually in the liquid form. An example that can help explain these terms is salt water. So basically in salt water, you have salt, which is a solute, you have water, which is the solvent, and then we have salt water, which is the solution. Now let's go to Ben in real time to look at the demonstration. Hey everyone, today we'll be making hot ice, or chemically called sodium acetate. So the materials you'll need are some vinegar, or acetic acid, some baking soda, or sodium bicarbonate, a glass container. For this experiment, I'll be using an Erlenmeyer flask, some aluminum foil, and a big old pot. In some circumstances, isopropyl alcohol, 70%, might be used to purify crystals. I already pre-measured 4 cups of the vinegar, and to that we'll be adding 4 tablespoons of this sodium bicarbonate or baking soda. So basically it's a 1-to-1 ratio. So let's add some baking soda. So here it goes. I'm using this knife to level off the baking soda. And we'll make sure to add it like one at a time because you don't want the pot to overflow. So you want to see what's inside the pot? Okay, so I'll add this baking soda to this vinegar, and we'll see what happens. Whoa, it fizzes up instantly. So cool, right? And then we add the second tablespoon. And it's reacting even more. And the third tablespoon. And finally, the 4th tablespoon. Look, it's so cool, right? I'm just gonna give this a quick mix. So currently our solution is very diluted, meaning that there's a bunch of water compared to the reactants. So how do we fix this? Well, we need to evaporate some of the volume. So let's head to the stove. So now we're at the stove. You can heat it at medium. So let's turn on medium. And let it boil out to a quarter of the volume. So it could take up to 30 minutes to an hour. So be patient. So I transferred the liquid to a smaller pot. As you can see, there is a thin film of crystals forming on the sides. And that's really good. And there's also a thin film on the top of the surface. So now we can transfer it to the beaker. We're going to transfer it through a funnel into the glass container. Now the solution is completely cooled, so I pre-cut a piece of aluminum foil, and now we're going to put it in the fridge. See ya around, sodium acetate. After taking it out of the fridge, it's time to get serious. Let's put on our gloves. And now we need to separate the solids from the liquids. So let's transfer the liquids into this bowl. Now, these are the crystals, and and as you can see, there's some discoloration. So we're going to use some isopropyl alcohol to purify it. Once you're sure that all the liquid is out, add 3 tablespoons of this isopropyl alcohol to purify it. And then mix with a chopstick or a spoon. In this case, I'll be using a chopstick since I'm Asian. Thorough mix. Yeah. You really want to purify it. Okay. And then repeat this process one more time. After purifying it as much as you can, heat it up either in the microwave or get a pot of boiling water and submerge the solution. So this water is already pretty hot, so I'm just going to put it in. And then just wait until it heats up. Once it turned back into its liquid state, put some aluminum foil back on and cool it to room temp. Once you do that, put it in the fridge and then take it out. After taking it out of the fridge for the second time, again, pour out the liquid into a separate container. As you can see inside the beaker, there's a bunch of crystallization already happening. Once you've taken out all of the liquid, pour the crystals into a microwave-safe glass container, or any container in general. And then, to this mixture of crystals, add a tablespoon of distilled water. And then, pop it in the microwave for 60 seconds. And allow it to cool to room temperature. After much trial and error, and through several processes of concentration and refrigeration, I turned a liquid into a solid. To test how amazing this solid actually is, here's a nail. Let's test the hardness. Look, it barely made a dent. You can always turn the solid back into a liquid whenever you want and impress your friends with it. If you're not fond of the color, you can always do some extra purification steps stated before in the experiment. Now, back to Slideshow Ben to explain to you guys the scientific concepts. Okay, so after the experiment, why does this work? Well, first off, with any experiment, there is a chemical reaction, and ours is no different. In this experiment, the chemical reaction is between the vinegar, which is a diluted form of acetic acid, or CH3OOH, and baking soda, which is NaHCO3, or sodium bicarbonate. When combined, it creates sodium acetate, carbon dioxide gas, and water. The goal is to remove the water and CO2, leaving only the sodium acetate, or what we call hot ice. The next concept in this experiment is neutralization. So this is one of the many types of reactions in chemistry, and it's when you combine acid and a base to produce water and a salt. So in this experiment, the acid was the vinegar, and the base was the baking soda. In this experiment, carbon dioxide was also produced, so it was kind of special. After is supersaturation, the main point of this experiment. The general definition of supersaturation is when there is more solute, the thing that's being dissolved, than usual. This happens when you heat a solution up to a very high temperature and cool it at a slow pace. These solutions are incredibly unstable, which is why by using just a small amount of leftover sodium acetate crystals, we were able to make such a big mass of hot ice. The final topic today is exothermic reactions. The reaction is basically the release of energy or heat. This happened from our experiment when the ice crystallized and it was very warm. Other exothermic reactions include fire or an explosion. In summary, you learned about superconcentration, solutions, exothermic reactions, and neutralization. Many of these concepts will be used throughout your journey in science, giving you a quick glance of what's to come. These concepts can also be used outside of school. For example, when making sugar syrups, superconcentration is involved. Anyways, thanks for watching and have a good day!